To calculate the area under a graph, to know the probability, one could of course do integration, but normally one uses probability tables instead. But the tables are given for a standard normal distribution, Z, not X. To read off a probability table, then you need a standard normal distribution. From a probability table, you can find out the probability of this red area here, and let's call that alpha. The value on the z-axis that will give the probability here equal to alpha, it's called z-alpha. For example, if this area has a probability of 10%, then this set here is called set 10%. So for this set, we will have 10% probability here. So per definition, we have that the probability to get a set value larger than set alpha, that is, you get an outcome here, is equal to alpha per definition. From this table, we can read off alpha, given set alpha. So if you know set alpha, then read off it here to one decimal and the second decimal here. Then you can go inside the table and find alpha. For example, let's say that we want to find out the probability for set being larger than 1. Here, set alpha is equal to 1. So we go here in the table to 1, and we have no second decimal then. So we read off alpha here, so 0.1587. So the probability is 15.87%. Note that it doesn't matter if I change this to this inequality sign, because if I include this point or not, it doesn't matter for the probability, since there are infinite many values you could take, so one more or less doesn't matter. Let's say I want to find out the probability to get a set less than 1 instead of greater than 1. So in this case, instead of finding the probability here, I want to find out this probability. But that's just 100% minus this one. So we have that 100% or 1 minus this probability is equal to what we want to find out. So here we have the complementary event to that one. Strictly speaking, we should put it like this, but it doesn't matter for the probability. And this one, we just read off from the table. So this was that, which means that we get the probability 84.13%, which is the probability we get an outcome here. Let's say you want to find out this probability instead. The probability table doesn't give you probabilities for negative set alpha, so you have to convert this to positive value here. But this probability is just this probability, and by symmetry that probability is equal to that one. So we have that it's equal to this probability, and that we already read off from the table. So it's like just this. So in this way we can read off negative values here also from the table. Then what about if I want to find out the probability to have a set between A and B? One sees from the figure that this probability we are seeking can be calculated by calculating this probability, that is set less than B, minus this probability, which is set less than A. And then we can read off this from the probability tables in the same way as we just have seen from the previous examples. So when given set alpha, you can figure out alpha from the table. But if you turn the problem around, what if you know alpha? How can you figure out set alpha? Then you can also find alpha inside the table, and then you can read off in the margin set alpha. For example, let's say that alpha is equal to 5%, or 0.05. What is then set alpha? That is, what is set 0.05. Then you just have to find alpha equal to 5% in the table, and that you see, you come closest to here. So between these two probabilities, for this probability you see it corresponds to set alpha 1.64, and for this one 1.65. So set alpha is between 164 and 165. So if you take the mean of that, we get 0.1645. So this is as good as you can read off set alpha from the table.